Okay, this is the first question. I took the question from past years and then we will try and answer it here. So this is tutorial 1, properties of fluid. Compressed air with a pressure of 300 kilopascal. So what we are dealing here is compressed air with a pressure of 300 kilopascal. Is stored in a cylindrical tank at temperature 30 degrees Celsius. So we can assume this is P absolute. So the pressure is 300 kilopascal or equals to 300 times 10 to the power of 3 pascal. And then stored a tank at a temperature of 30 degrees Celsius. So temperature is 30 degrees Celsius equals to 30 plus 273.15 equals to 303.15. Okay, and the tank diameter and height are 0.3 meter and 1.5 meter respectively. So the diameter is 0.3 meter and then the height is 1.5 meter. Okay, so we can assume the tank looks like this. Okay, so the height is 1.5. The diameter is 0.3. Having that info, we continue. Estimate the density, mass, and specific weight of the compressed air if the gas constant R is 0.287 kPa meter cube over kgk. So R equals to 0.287 kPa meter cube over kg. Alright, so these are the informations regarding this question. So we will continue with answering this. So this is a properties of fluid question. Because we can see this is compressed air. So the question says this is compressed air. So, and we have the pressure and temperature and also the gas constant. It means that this study will focus on ideal gas equation. So we can continue with the question first, finding the density. So to find out the density, first what you need to do is you need to provide this equation. PV equals to MRT, okay? And then this is also equals to P equals to rho RT. Okay, this is based from the definition of rho is equal to mass divided by volume. Okay, so to find out the density, we just have to rearrange the equation. Density is equals to P over RT is equal to 300 kilopascal divided by R 0.287 multiplied by T, which is 303.15. Okay, so the density should equal to 3.448. So density is 3.448 kg per meter cube. So we solve for the first question. Okay, if you can see from here, I'm using 300 because 300 is in kPa. And check again over here, the gas constant is also using kPa. If the gas constant is using Pa as the unit, you need to use 300 times 10 to the power of 3 pascal, okay, to cancel out between the gas constant and also the pressure. But since here we have kilopascal, so that's why I'm using 300, okay. So number 2 will be asking specific weight, and specific weight is just, estimate the density and mass, sorry. So the mass can be found by using this equation. Okay, density is equals to mass divided by volume. So mass is equal to density multiplied by volume. So we have the density here equals to 3.448, and the volume is based on that equation, pi d is 0.3 square over 4 multiplied by the height 1.5. Okay, so m should equal to so the mass will be 0.366 kg. Okay, all right. Let me check again. 3.448 times pi times 0.3 square divided by 4 times 1.5 equals to, okay, so the answer is 0.366 kg for the mass. Okay, and then the next one, number 3, should be the specific weight. Okay, so the specific weight is equal to rho times g. So the density 3.448 multiplied by 9.81. So specific weight should equal to 33.82. So 33.82 Newton per meter cube. Alright, so by having that, we are done with the first question. Okay, so this is the second tutorial on properties of fluid. Okay, this is from last year. So the specific gravity of a fluid is 1.35. So we write down the specific gravity. Sg is equal to 1.35. Okay, it means that the density for the fluid should be equal to 1.35 multiplied by 1000. So it should equal to 1350 kg per meter cube, right? So that will be the density of the question, okay? Oh, the density is one part of the question also. So this is how we get the density, or the equation for density should be rho equals to mass divided by volume, or if you have specific gravity, Sg is equal to rho of fluid divided by rho of water, which is 1000. So rho of fluid equals to Sg multiplied by rho of water. That's why we are using this equation over here to get the density. Okay, so if I write it back, it will be 1.35 times 1000 equals to 1350 kg per meter cube for density of fluid. That answers the first question. Number 2, the dynamic viscosity is 1.7 Pascal second. Okay, so the dynamic viscosity, this is question number 1. Number 2, dynamic viscosity is equal to 1.7 Pascal second. Estimate its density, we have the answer. Number 2, specific weight. And then number 3, kinematic viscosity. Okay, so this will involve kinematic viscosity. So this should be question number 3. So I solve question number 2 first. So question number 2 asks us about specific weight. once we get the density over here, specific weight is just equal to rho fluid times G, which is equal to 1350 multiplied by 9.81. So rho fluid is equal to 13,243. So 13,243.5 Newton per meter cube. Okay, so we cover the second question. And the third question, kinematic viscosity. Remember the equation for kinematic viscosity is equal to dynamic viscosity divided by density. So it is equal to mu 1.7 divided by density 1350. So the kinematic viscosity should equal to okay, so the answer is 1.259 times 10 to the power of -3, and the answer should be in meter square per second. Okay, continuing with chapter 1, we will have the second calculation, which is tutorial 3, viscosity. All right. So viscosity is a study of understanding the internal resistance inside a liquid. Okay. So tutorial number 3, viscosity. So a flat plate 60 cm times 120 cm slides on an oil over a large plane surface. Okay, so the specific, the dynamic viscosity is provided here, 1.04 times 10 to the power of -1 Pascal second. Assume linear velocity distribution. Estimate the force required to drag the plate at 3.5 meter per second if the oil film is 3 millimeter thick. Okay. The question over here does not provide you with any schematic diagram. So what you need to do is you have to draw one to get to know the idea of it. So it will be a simple surface on the top and at the bottom like this. Okay, so the thickness between these two plates should be 3 millimeter. Okay, and then assuming this part is non-moving, okay, and then we have oil over here. So in between we have oil, and then the surface area 60 cm multiplied by 120 cm. The velocity of the top plate is equal to 3.5 meter per second. And then the question asks us what is the force required to pull the plate at a certain velocity, which is 3.5 meter per second, right? So to continue with this, the first thing that you need to do is have to make sure that everything should be in meter. So it's easier for us to calculate. So 3 millimeter is equal to 1 meter, 1000 millimeter. So equals to 3. So this is 3 times 10 to the power of -3 meter. Okay. And then the area of surface is equal to 0.6 meter times 1.2 meter. So equals to 0.72 meter square, right? And then we have everything ready for the calculation. So the question asks us the amount of force required to drag the plate. Okay, so to do the calculation, it is force equals to mu A du dy. And since we don't have any du dy here, so we can change the equation into mu A v over, so it is equal to mu A v over the thickness. Okay, so mu is dynamic viscosity, A is the area, V is the velocity, and L is the thickness. So you can get the numbers from here. Mu is 1.04 times 10 to the power of -1. The area is 0.72. The velocity is 3.5 per second. Okay. And then you divide the velocity with the thickness, which is 3 times 10 to the power of -3. Okay. So the force required to pull the plate at a velocity of 3.5 meter per second is 87.36 Newton. That will be the answer for this question.